This is SpaceTime, Series 21, Episode 42. Coming up on SpaceTime, the ancient black hole providing new clues about the early universe, the first interstellar immigrant discovered living in our solar system, and new clues as to how Pluto was formed. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
An ancient supermassive black hole, more than 20 billion times the mass of our Sun, has been discovered in the very early universe. The findings, reported in the publications of the Astronomical Society of Australia and on the pre-press physics blog archive.org, paint a new picture of the early evolution of stars and galaxies in the universe more than 12 billion years ago. The newly discovered monster is growing incredibly rapidly, devouring a mass equivalent to the Sun every 2 days. One of the study's authors, Dr. Christian Wolff from the Australian National University, says it's the fastest growing black hole in the known universe. In fact, its growth rate equates to a 1% increase in mass every million years. As huge amounts of matter, entire stars, planets, and clouds of gas are drawn into the black hole's gravity well, the material is crushed, ripped, and torn apart, forming an accretion disk around the black hole, similar to water swirling around a drain before being sucked in. This tumultuous wreathing mass of superheated material on the accretion disk generates tremendous amounts of energy, shining brightly across the universe as powerful beams called quasars. And this supermassive black hole is growing so rapidly, it's shining thousands of times more brightly than an entire galaxy. Wolff says if this monster was sitting at the center of our own Milky Way galaxy, it would appear 10 times brighter than the full moon. In fact, it would appear as such an incredibly bright pinpoint of light, it would almost wash out all the other stars in the sky. The energy emitted from this quasar was mostly ultraviolet light, but it also radiated very powerfully in X-rays. X-rays with enough energy to wipe out all life on Earth, were it, as in the earlier example, the center of the Milky Way galaxy, some 26,000 light-years away. The energy emitted by the black hole has been stretched into the near-infrared by the expansion of the universe over the past 12 billion years. The newly discovered behemoth was detected by the ANU SkyMapper telescope at the Siding Spring Observatory in western New South Wales. Wolff says these large and rapidly growing black holes are exceedingly rare, and his team have been looking for them with SkyMapper for several months. The European Space Agency's Gaia satellite, which measures tiny motions in celestial objects, helped identify the quasar because to Gaia it appeared to be sitting still compared to other celestial objects. That's because it's so far away, and that made it a great candidate for a very large quasar. Once identified, the discovery was confirmed using the spectrograph on the ANU's 2.3-metre UK Schmidt telescope, also at Siding Spring. The UK Schmidt split the light from the quasar into its spectral lines, allowing astronomers to determine its redshift. Wolff admits science still doesn't understand how this black hole could have grown so massively, so quickly in the early universe.
We've been looking for quasars, especially quasars at high redshift in the early universe, for quite a while now, for over half a year. SkyMapper is a bit late to that game because a lot of quasars in the early universe have been found by the Sloan Digital Sky Survey already a decade and more ago in the northern sky. And SkyMapper is now the first survey that really goes to similar depth studying the southern skies. So here we are, we have entered the field, we found a few around Christmas time, but really what we want to do is push the envelope and really get good demographics of the fastest growing and most massive black holes in the universe. And so what we were able to do now for this particular object is combine our SkyMapper view of the southern sky with the optical and a bit near-infrared colors with two more data sources. One was a NASA satellite called WISE, the Wide Field Infrared Survey Explorer, that helps you differentiating these high redshift quasars from not so interesting for us anyway, nearby galactic stars. And then also what is brand new data set is the European Space Agency's Gaia satellite.
It just had its latest release the other week of information.
Just a few weeks ago. And that included crucial information. And what the Gaia satellite is doing, it is basically able to measure extremely precisely locations and tiny motions of celestial objects. And it really does that in order to sort of map out the streaming motions in the Milky Way and study our own Milky Way galaxy predominantly. What we also can do is quasars are supposed to be at really, really large distances, and especially when we believe they are in the early universe, then they're not supposed to move at all, as opposed to the foreground stars of our own Milky Way. And so we were able to read out our candidate lists. We're trying to look for these high redshift quasars, and then because their colors are similar to cool stars in our own galaxy, our list of possible high redshift quasars are polluted with vast amounts of Milky Way stars that we're not really interested in. And when we want to know what a particular object is, we have to point a spectrograph at it at a somewhat bigger telescope, and then we have to check them off one by one. So what is this exactly? Is this a star now? Take the spectrum. A star. This one over here, is that? Let's take a spectrum, another star, and so on. And you can't afford to go through all of them because there would be millions of candidates. So really, Gaia has helped us to weed out a lot of this contamination by Milky Way's foreground stars. It doesn't completely remove that. We still find stars among our candidates, but at least it's now become realistic to find these very rare and very fast-growing, very bright quasars.
How does a supermassive black hole grow so big so early in the history of the universe?
Well, that is a mystery. We see this is not the first case where we see a really big black hole in the early universe. It's merely the most extreme case we've found so far. And it's also demonstrated to us that apparently some of these extreme cases really have been overlooked, and we certainly are going to look for more of them, and as I said before, get the demographics of these things. But it's been acknowledged already before that it's a bit of a problem, because when we feed black holes, when you just drip feed them a little bit, matter can just sort of stream in and fall in, and it's fine. But if you throw a lot of matter at a black hole is a fairly small thing in space. It may have a lot of mass, but that mass is very concentrated. So the spatial extent of a black hole is actually fairly small. You could have the mass of millions of suns, and the whole black hole would only have the size of, say, the solar system. So as you get a lot more mass flowing towards it and trying to fall into the throat of the black hole, it gets pretty crowded, and all these gas clouds streaming in that are either, interstellar gas from that galaxy that gets absorbed, or they are disrupted stars that have been torn apart into gas streams. They stream in, it gets pretty crowded, you get friction, and heat builds up. And that's actually why we see these quasars. That's what makes them glow. It's that heat radiation from the gas that gets thousands and eventually millions of degrees hot before it crosses the event horizon, and then we can't see it anymore because no light can come out anymore. So, and this heat radiation actually tends to blow out the next gas in line that wants to fall in next. And so we've got this balance between the gravitational attraction, but also the heat radiation blowing out the gas. And as a consequence of this balance, we believe that there's a bit of a speed limit for the growth of black holes. And the more mass a black hole already has, the more it can absorb. So it's a relative speed limit. We believe that a black hole can grow by about 1% in mass every 1 million years of time. So bigger black holes can absorb mass more quickly, but it's relatively speaking, it's the same rate. So you get an exponential growth in the mass of a black hole. And if we take this one and we calculate backwards in time, we see this black hole about 1.2 billion years after the Big Bang. So we see it way in the past. But we've got a billion years or so to play with. We calculate backwards and we assume that this black hole has grown at the speed limit without ever taking a break. As we get close to the Big Bang, we come out to something like 5,000 times the mass of the sun. So this black hole would have needed to start at 5,000 times the mass of the sun and then grow by sucking in lots and lots and lots of matter. And we don't know how to make black holes of 5,000 times the mass of the sun. We know how to make black holes of 50 times the mass of the sun. That's fine. We get that regularly as a result of a massive star reaching the end of its life and then having the core collapse into a black hole, and the outside of the star, the atmospheres get blown away. In
Could population 3 stars be 5,000 times the mass of the sun at that point in the universe's evolution?
So you're right to think about population 3 stars and their role in this problem, because population 3 stars are supposed to be on average more massive. The point with the population 3 stars that are free of heavy elements in the early universe, after the Big Bang we only had hydrogen and helium really to make stars from. The problem there is that you have a lack of cooling. You actually need dust from heavy elements like carbon and iron and so on and silicon to cool the birth clouds of stars. And without this cooling, we can't make small stars like the sun. We can only make big stars. But at this point, we have no evidence that these stars could have been much bigger than the stars that we form nowadays. So we probably had more of the big stars and perhaps none of the small stars. But how big could these stars have been? It's not reckoned that they could be in the range of thousands of solar masses. Maybe they could reach 200 or something, and but not 5,000. And so this conundrum with the growth of the early black holes has, well, you know, if you try to consider every possible angle, you could come up with 4 scenarios, some of which we don't really want to entertain. One is maybe that speed limit to growth is just wrong. Black holes can grow faster. We don't know how to make that. We haven't seen that happening, but maybe it happens and we just need to learn.
There have been other cases where people have questioned that Eddington limit too, haven't they?
Yes, it has been questioned, but the problem is that, I mean, the Eddington limit is constructed by the feedback, the power of the radiation, the heat radiation, to stop the matter from falling into the black hole. And having the infall create very little heat and thus have very little power to stop further infall, that we see that happening, but we see that predominantly happening when you drip feed a black hole. Then you create very little heat, you get very little force pushing back out, but that's not a solution to our scenario, because we don't look for a drip feeding scenario. We look for a scenario where a black hole might be really scorching down enormous amounts of mass, and we haven't really seen that happen. But it's a possibility, it's one way out. The other way out is to make very massive black holes already very early after the Big Bang, or possibly as part of the Big Bang. That would be one way.
The universe was a lot denser back then. Things were a lot closer together.
Yeah, though we don't know how to make that, right? I mean, how the Big Bang itself could make black holes, that would really be a new chapter in the physics and cosmology book. Certainly not ruled out. We've had a number of surprises over the last century in terms of what's happening in the universe, but still difficult to explain in detail. The third one is that perhaps really we had more time than we think. So we got the numbers around the early evolution of the universe and the Big Bang wrong. But that's an unlikely one. This hypothesis has a few friends, but very few friends, because we have so much information from different types of observations that seem to indicate that our picture is really consistent and the timelines are what they seem to be, with a Big Bang about 13.5 billion years ago. And then the fourth one, and that is a possibility, is that you may only form black holes of 50 solar mass from the collapse of stars. But if you have many of these, you could perhaps merge them very quickly into something like a 5,000 solar mass black hole that then could grow by accretion within the Eddington limit. So this merger component, that might change something. You mentioned correctly that the universe was a lot denser at that point in time. The galaxies were all individually closer together because we had the same amount of galaxies essentially in a much smaller space. On the other hand, the galaxies individually were much, much larger. So stars still had a similar distance from each other like they have today in the Milky Way. And perhaps what helps is that the dynamics was different in the early universe. Nowadays, when you look at the Milky Way and other galaxies around us, you get a lot of this ordered rotation. The disk with spiral arms in the Milky Way. All the stars are showing this ordered rotation. Everything looks very civilized. If you look at galaxies in the early universe, you have much less ordered disk-like rotation in them. You have a lot more chaotic motions, like the molecules in a gas. Every star is going in a different direction. They all have their orbits that are quite unrelated to each other, rather than being in a common plane with ordered rotation. So it could be possible that as part of this more chaotic dynamics, that it was much easier to lead bodies to mergers than it is nowadays in the ordered rotation, where you hardly ever get collisions or any merging events. That could help to have a way out there.
That's Dr. Christian Wolf from the Australian National University. And this is Space Time. I'm Stuart Gary. A new study has discovered the first known permanent immigrant to our solar system. The asteroid, reported in the monthly notices of the Royal Astronomical Society, is currently nestling in the orbit of Jupiter. It's the first known asteroid to have been captured from another star system. The new discovery comes in the wake of Oumuamua, the first known interstellar visitor to our solar system. But while Oumuamua was just passing through, this newly discovered exoasteroid, known as 514107 2015 BZ509, is a long-term resident. We know it's come from somewhere else because all of the planets in our solar system and most other objects orbit the Sun in the same direction, which was determined by the rotation of molecular gas and dust clouds as they collapsed to form our solar system 4.6 billion years ago. However, 2015 BZ509 is different. It's moving in the opposite direction, in what's known as a retrograde orbit. And celestial bodies orbiting in retrograde are usually captured objects. The authors ran computer simulations to trace the movements of 2015 BZ509 right back to the birth of our solar system. However, the simulations indicate it's always been in retrograde, and so was most likely captured from another system. The migration of planets, asteroids, comets, and other celestial objects between star systems is thought to have been fairly commonplace, as dozens to maybe even hundreds of stars in the surrounding planetary systems all formed together in their tightly packed stellar nurseries created through the collapse of molecular gas and dust clouds. The gravitational forces of stars and planets in such close proximity to each other help these individual systems attract, remove, and capture planets and asteroids from each other. The discovery of this first permanent asteroid immigrant to our solar system has important implications for planetary formation, solar system evolution, and the very possibility of the origins of life itself. So understanding exactly when and how 2015 BZ509 settled into our solar system will provide important clues about the Sun's original stellar nursery and about the potential enrichment of our early environment with components necessary for the appearance of life on Earth. I'm Stuart Gary. You're listening to Space Time. A new study suggests the distant frozen world of Pluto may have started out as a giant comet. The findings, reported in the journal Icarus, are based on observations of the nitrogen-rich ice sheets spread out over vast areas of Pluto's Sputnik Planitia region. Sputnik Planitia is a huge glacial expanse rich in nitrogen, carbon monoxide and methane gases that forms the left lobe of that bright heart-shaped feature on the dwarf planet's surface known as Tombaugh Regio. The study's authors carefully examined nitrogen and carbon monoxide compositions to develop their new theory for Pluto's formation. Scientists found an intriguing consistency between the estimated amount of nitrogen inside the glacier and the amount that would be expected if Pluto was formed by, say the agglomeration of roughly 1 billion comets or other Kuiper Belt objects, which would be similar in chemical composition to the comet 67P Churyumov-Gerasimenko. The Kuiper Belt is this giant ring of frozen worlds, comets and icy debris which circles the Sun out beyond the orbit of Neptune. The authors reached their giant comet cosmochemical model of Pluto's formation by combining data from NASA's New Horizons mission to the Pluto system and the European Space Agency's Rosetta mission to comet 67P. One of the study's authors, Dr. Christopher Glenn from the Southwest Research Institute in San Antonio, Texas, says the data explains how a 2,400 kilometre wide dwarf planet could have formed at the edge of the solar system. In addition to the comet model, the authors also investigated a solar model, with Pluto forming from very cold ices that would have had a chemical composition that more closely matches that of the Sun. Scientists needed to understand not only the nitrogen present at Pluto now, in its atmosphere and its glaciers, but also how much of the volatile element potentially could have leaked out of the atmosphere into space over the eons. They then needed to reconcile the proportion of carbon monoxide to nitrogen in order to get a more complete picture. Ultimately, the low abundance of carbon monoxide at Pluto points to burial in surface ices or to destruction from liquid water. The findings suggest that Pluto's initial chemical makeup, inherited from cometary building blocks, was chemically modified by liquid water, perhaps even in a subsurface ocean. However, the solar model also satisfies some constraints. But while the researchers pointed to some interesting possibilities, there are many questions that still remain to be answered. You're listening to SpaceTime. I'm Stuart Gary. An Antares rocket has successfully blasted into orbit, carrying 3 tons of scientific experiments and equipment bound for the International Space Station. The orbital ATK Antares, carrying the Cygnus A09 cargo ship, was launched from NASA's Wallops Island Flight Facility on the Virginia mid-Atlantic coast.
Preliminary fuel tank pressurization started.
Roger that, Core 1. Wallops on best source telemetry. T-minus 5, 4, 3, 2, 1.
And Antares lifting off, going across the night sky, disappearing through some clouds quickly and coming quickly back into view. The first stage looking nominal or normal so far, lighting up the night sky there above Virginia. Orbital ATK's Antares on its way.
The Cygnus arrived at the International Space Station 3 days after launch. It was captured and manoeuvred into its docking port on the Earth-facing Unity module using the orbiting outpost's robotic arm, as both spacecraft were flying at 28,000 kilometers per hour, some 425 kilometers above the southern Indian Ocean. Included in the manifest aboard Cygnus is new equipment for some 250 scientific experiments now being performed on station. Among the more unusual items is a handheld sextant, a centuries-old celestial navigation device. It'll be part of an experiment designed to see how well it works for emergency navigation on deep space missions, allowing crews to sight angles between the moon or other planets and stars to find their way home again if communications and main computers are compromised during deep space missions. Of course, it's not the first time a sextant has been used in space for navigation. The crew of Apollo 8, the first manned spacecraft to leave Earth orbit, used the sextant to confirm the performance of their spacecraft's navigation computer to fix its position during their journey to the moon and back. Also aboard Cygnus are new experiments monitoring the crew health and the biological environment of the space station. One of these studies, called BEST, which stands for Biomolecule Extraction and Sequencing Technology Study, will continue advancing in-space DNA sequencing technologies to help identify microorganisms living on the space station and understand how the DNA of humans, plants, and microbes are affected by microgravity. Another experiment delivered to Cygnus, this one dealing with physics, is CAL, the Cold Atom Lab. It's designed to create temperatures close to absolute zero, using lasers and magnetic forces to slow down atoms until they're almost completely motionless. CAL will be able to observe these ultra-cold atoms in the microgravity environment of the space station for much longer than possible on Earth. The research could point the way to a new generation of sensors, quantum computers and atomic clocks for future space navigation. Cygnus also carried 3 CubeSats that'll test new technologies for Earth observations. CubeSats are tiny self-contained satellites, each about the size of a loaf of bread. RAINCube is the tortured acronym for Radar in a CubeSat, a miniaturized radar to study precipitation, in fact the first active radar instrument to be flown on a CubeSat. Then there's the CubeSat Radiometer Radio Frequency Interference Technology Validation Mission, or CubeRRT. It'll test new technology to try and reduce RFI or radio frequency interference, which is a growing problem for space-based instruments trying to study soil moisture, meteorology and climate from orbit. The third CubeSat, TEMIS-D, Temporal Experiment for Storms and Tropical Systems Demonstration Satellite, will use new miniaturized radiometer technology in the hope of eventually building entire flotillas of CubeSats to study developing storms and provide shorter time intervals between sending that information so that the information the weather forecasters get is as up-to-date as possible, something that may not necessarily be possible with some larger satellites. Once unloaded, Cygnus will be filled with several tons of space station trash. It will then be undocked in July and allowed to burn up during re-entry into Earth's atmosphere over the eastern southern Pacific Ocean. I'm Stuart Gary. You're listening to SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. New research suggests that long exposure to traffic-related pollution significantly increases the risk of asthma, especially in early childhood. The findings, reported in the Journal of Allergy and Clinical Immunology, are based on studies involving 1,522 Boston area children between 1999 and 2002. Scientists looked at how behavioral and environmental factors, such as sleeping and eating habits or exposure to pollution, impacted children's health. They found that children living less than 100 metres from a major road were nearly 3 times as likely to have asthma and needing daily medications by the ages 7 to 10 compared to kids living more than 400 metres away from a major road. While physicians have long known that smog and pollution can bring on an asthma attack, researchers remained uncertain about what role long-term exposure to certain pollutants might play in the development of the disease in children. In America alone, some 25 million people suffer from asthma. It's a chronic lung disease which has been on the rise, especially in Western civilization, since the 1980s. A new study says limiting global warming to 1.5 degrees Celsius would save the vast majority of the world's plant and animal species from climate change. The findings, reported in the journal Science, reveals that limiting warming to the ultimate goal of the Paris Agreement would avoid half the risks associated with global warming of 2 degrees for plants and most animals, and 2/3 of the risks for insects. Species across the globe would benefit, but especially those in southern Africa, the Amazon, Europe and Australia. Reducing the risks to insects is especially important because they're so vital for ecosystem services such as pollinating crops and flowers and being part of the food chain for other animals. This is the first study to explore how limiting climate change to 1.5 degrees Celsius would benefit species globally. The researchers, which included scientists from James Cook University, studied some 115,000 species, including 31,000 insects, 8,000 birds, 1,700 mammals, 1,800 reptiles, 1,000 amphibians, and some 71,000 plant species in what was the largest scale study of its kind ever undertaken. Archaeologists on the Palestinian West Bank have unearthed a rare ancient coin dating back more than 2,000 years. It was discovered by a joint archaeological team in a cave some 30 kilometres northwest of Ramallah. The coin was minted either in the 3rd or 4th year in what's known as the Bar Kokhba revolt by Jews against the Roman Empire, which lasted from the years 136 to 134 BCE. One side of the coin shows a palm tree with 7 fronds and 2 clusters of fruit, as well as the inscription Shimon. The other side portrays vine leaves with 3 lobes and the inscription to the freedom of Jerusalem. Alongside the coin, archaeologists also discovered pottery fragments and glass vessels which can be dated to the same period. The coin was discovered during a multi-university archaeological survey of various historical digs in the West Bank. Archaeologists believe the items would have been brought into the cave by Jewish refugees who were forced to leave their homes and hide there at the height of the revolt. The Bar Kokhba revolt was a rebellion by Jews in the land of Judea led by Simon Bar Kokhba against the Roman Empire. It took elements of 6 Roman legions to finally crush the rebellion. In an attempt to erase any memory of Judea, the ancient land of Israel, the Emperor Hadrian wiped the name Judea off the map, moving its inhabitants into slavery and dispersing them to the far reaches of the Roman Empire. The entire region was then renamed Syria Palestina by the Romans, of which the ancient land of the Jews became modern-day Palestine. You're listening to SpaceTime. I'm Stuart Gary, and that's the show for now. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.